Hi, welcome back to My Smart Learning. This is a lesson for Year 10s. We're looking at the electrical circuits topic in Chapter 4 and 5 from your Physics Computer textbook. It's useful for all Year 10s. I know I've sort of designed this stuff for 10S and 10T, the classes that I've been teaching, but everybody in Year 10 could be using this whether you're separates or not, because it's the trilogy stuff, but it's also for the separates. So anybody in the whole of Year 10 can use this, and it's extra revision for you. So whether you do the questions or not, it doesn't really matter. Just watch the videos because I'll go through some content that'll be useful for you. So we're looking at electrical energy today, and our learning objective is how are current, charge and energy related? What's the relationship between those? But before we start that, you know, I like my virtual high five to get. You can't buy those in the shop. So recall quiz, high five. Number one, what is the formula for Ohm's law? V equals something. We did this a couple of weeks back, so if you can remember that, it was actually before Easter. Question 2, what is Ohm's law? Can you state Ohm's law? Okay, that's question 2. Write these down. Question 3, efficiency is what we did last lesson. Can you write down the formula for efficiency? And question 4, we learned last week 3 different equations for power. Can you write all 3 down, please? And the last one, what is the unit of power? What is the unit of power? So press pause, have a go at those questions, and when you're ready you can unpause it and we'll go through the answers. Right, so formula for Ohm's law, V equals IR. So voltage equals current times resistance. If you want to rearrange that, the resistance is the voltage divided by the current. So V equals IR, I stands for current, R stands for resistance, V stands for potential difference of voltage. Ohm's law states this: the current is directly proportional to the voltage applied, or the potential difference applied, as long as the temperature remains constant. Now if you remember the graph, it was just a straight line going up. You had a V there, you had an I there for current, and you had a straight line from the origin, from 0, going up in a straight line like this. So V equals IR, which is that is the Ohm's law formula. The statement is this: the current is directly proportional to the voltage applied as long as the temperature remains constant. The wire can't get too hot. Efficiency is the useful energy divided by the total energy, the total input energy, times 100%. The 3 equations of power were, power is energy divided by time. That's the first one. The second one was power equals voltage times current, or current times voltage, P equals IV. And the last one was P equals I squared R. Power is the current squared times the resistance. So those are all these formulae, those 5 that we've just done now, you need to memorize. You need to commit them to memory. Just how I just spat them out like that, you need to be able to do that for your exam, okay? Because you need to use them for exam questions. And what is the unit of power? Yes, that is not a question, it's a statement. What? So watts are the unit of power. So let's move on then. Calculating current. How do I calculate current? Q equals IT. You're going to have to memorize another 2 formulae today. So those 5 that I've just gone through, today we're going through another 2 more, and you've got to, again, commit them to memory. You've got to have to drill it into there. Just like for your maths GCSE, all the formulae you need to memorize, or your equations, same thing for your physics. So Q is the symbol for charge, I is the symbol for current, T is the symbol for time. So the units though, charge is measured, this capital C represents coulombs. That C doesn't represent charge, it's just the units of coulombs, C-O-U-L-O-M-B-S, coulombs. The current is in amps. The time must be converted into seconds. So if you've got 1 minute, you're going to make that into 60 seconds. So here is the formula: Q equals IT, or quit. Q equals I times T. I remember it as quit. Q is that there, the charge. So this is the charge in coulombs. This is the current in amps. This is the time. If I curve the Q, if I want to work out the charge, it's current times time. If I want to work out the current, I put my hand over the I. The current is the charge divided by the time. So it's coulombs per second. So 1 amp of current is 1 coulomb per second. It's literally just watching the current flow through. Now we did go through current at the beginning of the topic when we looked at the circuit diagrams. This was a long time ago when we were back at school, many weeks ago, before the lockdown. We did start the topic by looking at the circuit symbols, the circuit diagrams, and we did look at the definition of what current is. So we may have done these questions before. So Q equals IT, I is Q over T. It's the amount of charge, electrical charge, flowing past the point every second. So here's some questions for you. Make sure you've written down Q equals IT for you to have a go at. Pause the video, or I've also posted it on Show My Homework, the PowerPoint, so you can have a go at it from there. And then after you've had a go, unpause the video and we'll go through the answers. So if you've had a chance to do that, let's have a go at these together then. And we are looking at question 1. The question is asking me how much current is flowing through. Remember, current, Q equals IT. So I'm looking for current, which is I. So current with the I, it's Q divided by T. Well, the Q is 100. So I have 100 coulombs divided by 25 seconds, obviously is 4. So this one is 100 divided by 25 equals 4 amps. So for question 1, it's 4 amps. Make sure you write the formula out each time. Make sure you've rearranged it if you need to, or written the right way around. Substitute the numbers in. Show the examiner that you put the numbers into the right place. Then do equals. Write the answer down separately to the rest of the working out. And you must underline the answer with 2 lines to show where the actual answer is. Okay? And the next most important thing, you must not forget the units. Make sure you put the units in. So many people lose marks for not putting the units in. So if it's current, the unit is amps. So you have to put 4 with a capital A next to it. A for amps. You can't put a little a. You have to put a big A. Okay? So make sure you get it correct. Question 2 then. In a toaster, the circuit drew a current of 10 amps. So I've got my current and a charge of 1,200 coulombs had flown through it. How long was it on for? So this one is how long. Underline the word long. It's how long. It's the time. So I want T. So T is going to be Q divided by the current, Q over I. So the Q is 1,200. The I is 10. So 1,200 divided by 10, I'm literally just cutting off a 0. So the answer is 120. 120 what? Not 120 watts. 120 what? 120 minutes? No. 120 seconds. It has to be in seconds. Time has to be in seconds. 120 seconds for question 2. So you need to put a little s, not capital S, little s for seconds. But you can convert that into minutes. So 120 seconds is 2 minutes. Right, question 3 then. A motor operates 6 volts and draws a current of 3 amps. The motor used for 5 minutes. Calculate the charge flowing through it. And remember what I said, Q equals, we want the charge, Q equals IT. So we've got the I and I've got the T. So Q equals IT. I is 3, so I'm going to do 3 times 5. Am I right? No, because I'm not going to use 5. I need to convert the 5 minutes into seconds. Time has to be in seconds. So 5 minutes needs to be 5 times 60, which is 300 seconds. So that needs to be 300 seconds, and that's going to be 3 amps. So 3 times 300 seconds, the answer to question 3 is 900, what? 900 coulombs. So charge is measured in coulombs, so you need a capital C next to that. Okay, so capital C for coulombs. And then question 4, a lamp is attached to a 12 volt circuit and a charge of 1,200 coulombs flows through it. If the lamp is on for 10 minutes, calculate the current. So again, current is charge divided by time, Q over T. The Q is 1,200 divided by the T, which is the time, which is 10 minutes. Do I do 1,200 divided by 10? No, I don't. I need to convert my time into seconds. So 10 minutes is 10 times 60, which is 600 seconds. So 600 seconds is on for. I've got 1,200 coulombs going through it. So 1,200 divided by 600 seconds equals 2. So that answer is 2 amps. Okay, 2 with a capital A. So if you've got that, that's fantastic. If you're not sure, go back and have a look at it and go back to the previous slide with the equation as well. Next thing, the last thing we will look at today is another equation. Now, energy and charge, the relationship between energy and charge. The amount of energy that flows in a circuit will depend on the amount of charge carried by the electrons and the voltage or the potential difference pushing the charge around. How much energy is pushing that charge about. So the energy transferred, E, because energy is E, energy in joules, equals the charge times the potential difference, or the voltage. So it's going to be Q times V. E equals QV. So it looks like that. So E equals Q times V, or V times Q. It doesn't matter either way around, it's the same thing, right? But I remember it as E equals QV. So if I want the energy, cover up the E. It's the voltage times the charge, or the charge times the voltage. If I want the voltage, I cover up the V. It's the energy divided by the charge. And if I want the charge, I cover up the charge there. It's the energy divided by the voltage. So let's have a go at some questions, some exam questions here. It's going to make it a bit more trickier now. So can you pause the video, have a go at the questions on line paper or in your book, and then I'll go through the answers after you've unpaused the video. You will need your calculators, obviously, like you did from the previous one. So let's have a go through the answers if you unpaused it now. Exam questions. Number 1, in a radio circuit, a voltage of 6 volts is applied. Always circle the numbers. Okay, so circle the numbers. Obviously, you can't circle your computer screen or whatever, or your mobile phone. It's obviously on a piece of paper. Circle the numbers, highlight the numbers, underline the numbers. Make sure you can see where the information is. The important information is in the question. So, voltage is 6 volts applied and a charge of 100 coulombs flowing through it. How much energy is transferred? Now, E equals Q times V. So, literally, it's the Q, which is 100, times the V, which is the 6. 100 times 6 equals 600. So question 1, the answer is 600. 600 what? It's the energy I'm looking for, so it's 600 joules. 600 joules. In this circuit, it's talking about this one there. It's the previous question. Don't get confused by that. In this circuit, which is from the previous question, the radio circuit, the radio drew a current of 0.5 amps. How long was it on for? Now, I need to use my first equation from the previous slide, okay, the first slide. How long was it on for? Well, time is Q divided by the current. Well, we know what the Q is. The Q is 100. So the Q is 100 divided by the current will give me the time. So 100 divided by 0.5 is the same as saying 100 times 2, because if you divide it by half, your time is going to go by 2. So 100 divided by 0.5 equals 200. 200 what? How long? Time. 200 seconds. It has to be in seconds. So you've got 200 seconds, but you can convert that into minutes if you want to. 60 plus 60 plus 60 is 180. So that's 3 minutes gone, and then there's 20 seconds left. So it's 3 minutes and 20 seconds. Okay, now we're starting to get a bit more trickier. Now you have to start thinking. A motor operates at 6 volts and draws a current of 3 amps. I'm going to circle that number, I'm going to circle that number. So I've got V and I've got I. The motor is used for 5 minutes. I'm going to circle that number. 5 minutes is, I need to convert that into seconds, so that's 300 seconds. Calculate the motor's resistance. Okay, now we're using all those equations that we've been learning over this whole topic. The first equation was V equals IR. Okay, V equals IR, so the resistance R is V divided by I. So V divided by I, so 6 divided by 3 is 2. So the resistance is going to be 2 what? 2 resistance, units of resistance? Ohms, the little horseshoe shape, okay? 2 ohms. So the resistance for question A, 3A is 2 ohms. Now calculate the charge flowing through it. So Q equals what? There's 2 formulas of Q. You've got Q equals IT. There you go. I got I and I got T. So I is 3. T is not 5 minutes, it's 300 seconds. So it's going to be 3 times 300 seconds. So the charge again is going to be 900 coulombs. And then the energy supplied to it. The energy supplied to it, E equals QV. We just learned that from this previous slide. E equals QV. So the Q is what we just calculated from part B. So that was 900 coulombs. 900, so Q, V is 6. So 900 times 6 volts. 6 equals 5,400. Okay, because 9 times 6 is 54. Put 2 zeros after it. So it's 5,400 joules of energy. If you wanted to convert it, you could put it into 5.4 kilojoules. So that's how they get tricky, where you have to use bits of different equations. You've got different equations going on here, taking information from one part of a question and putting it into another part of the question. This is the kind of standard you're expected to do for GCSE Science Trilogy, for your physics component, and also for obviously GCSE Physics. Make sure you don't forget the units. Right, last question for today, and then we'll call it a day. A lamp is attached to a 12-volt circuit. So I've circled that, I've got my 12V at a charge of 1,200 coulombs. Again, I'll circle that bit there. It flows through it. If the lamp is on for 10 minutes again, I've got another 10 minutes. I need to circle that, and I need to make sure I put that into seconds. So that's going to be 600 seconds, because 10 times 60 is 600. So I've got 600 seconds there. Calculate the current again. Well, current is Q divided by T. Because Q equals IT, so I is Q over T. So Q is there, the T is there. So I've got 1,200. 1,200 is my Q. My T is 10 minutes, which is 600 seconds. So that's going to be easy. So 1,200 divided by 600 equals 2. So my current is going to be 2 amps. What's the resistance in this circuit? Well, the resistance, remember we did it from V equals IR. So V equals IR. My resistance R is going to be V divided by I. Well, I've got 12 volts here. I've just worked out my I, which was 2. So it's 12 divided by 2 amps from the previous part of the question. So 12 divided by 2 equals 6. So the resistance is 6 ohms. Okay, 6 ohms. The energy supplied to the bulb, E equals QV. E equals QV. So Q, which we just did a few minutes ago or a second ago, we've got the V, which is 12. So I've got my 12 volts equals QV, and my Q's here, isn't it? My Q's there, which is 1,200. So I've got 1,200 times 12 equals 144. It should be 14400. So it's 14,400. 14,400, or 14.4 kilojoules, or 14,400 joules of energy, because that's the energy supplied. Because E equals QV, Q is there, and the V is there. Okay, and the resistance we have to use from V equals IR. So that's today's lesson then. So we've just added on 2 more formulae for you guys to learn. So we had all those ones at the starter, and then the 2 extras that we learned today was Q equals IT, quit, please don't quit, and then E equals QV. Okay, E equals QV. So I need to be able to apply it to exam questions. On your Show My Homework, I've uploaded the file, the PowerPoint, with all the questions and stuff on it. Please use it. There's also extra questions which you'll see on the next few slides. Okay, so you've got some extra questions there, some key points to get into your notes. If you've learned something from my Smart Learning, from me, okay, and you've learned and it's been useful for you, please like the videos, make comments if you want, as long as they're appropriate. Please share the videos with your friends so other people can learn. It's useful for all year 10s and 11s. And please subscribe, and please share so other people are as well. So I'll see you next time. Look after yourselves, and if you got all 5 questions right from your starter activity, your virtual high five, your recall PT, your high five, then you get a virtual high five from me.